Yeah, this might be slightly off topic, but I just want to ask you, I don't really know a lot of research going on regarding the aging of other organelles in the cells, such as the Golgi apparatus and so on.
Okay, so simple, quick answer. The thing about everything essentially that goes on in the cell is that everything's functional anyway, is that it's relatively short-lived. Everything gets turned over at a reasonable rate. And therefore, DNA is really the only problem, with the exception of course, stuff that does not get turned over because it can't be broken down, the accumulation of molecular garbage in the lysosome in particular. Or indeed, as we will probably be hearing from David Rubenstein in a minute, molecular garbage that's not necessarily in the ribosome, in the lysosome, but probably only because the lysosome is already broken for some other reason. So turnover is the essential answer. Everything that doesn't have its own genome is pretty much secure.
Okay, well, one more question and then the end.
I just wanted to ask you, do you consider manipulating pH as a way to affect mitochondrial mutation? Because in an acidic environment, the rate of ATP hydrolysis is increased, which may increase mutation, while alkaline environment can be protected.
I think that significantly manipulating the pH of any compartment, whether it's the inside of the mitochondrion or the cytosol or indeed the bloodstream, is probably a non-starter, because the body and indeed the cell appears to be very keen on keeping pH extremely under control. There are some famous experiments done by various crazy scientists a long time ago. J.B.S. Haldane was one of them, if I remember rightly, trying to change the pH of their own blood, and succeeding briefly and suffering quite substantially as a result. So I don't recommend